Okay, let's get started. Hi everyone, thank you for coming, and welcome to this talk titled Insights on Sysbench and Custom Benchmarks. Here's the agenda for this talk. I'm going to start with a brief introduction to Sysbench, talk about some new features and recent versions, and some of the features that I'm currently working on that you can expect in the future releases. And then we are going to see the live demo of Sysbench presented by Martín. A few words about us. I'm Alexey Kopytov. I live in Moscow, in Russia. Yay for the World Cup. Yes, and I've been with MySQL for almost 15 years, and most of this time I've been dealing with issues requiring analyzing MySQL performance and sometimes fixing it. So I needed a good tool to work on MySQL. I needed a good tool to analyze MySQL performance, and that's why during all these years I've been working on, I've been developing and maintaining Sysbench. And my co-speaker today is Martín Arrieta.
Yeah, I'm lead database consultant at Pythian, based in Uruguay. So long flight from here, and yeah, I'm a developer as a hobby, but mainly DBA for quite a few years, and system administrator before that. So yeah, and I'm going to be making the demo, and he will be explaining a bit more at the very end. So go ahead.
Okay. So here's a brief introduction to Sysbench. Sysbench is a load generation tool, and it supports multiple possible targets for load generation. It has this bundled benchmark called OLTP, which supports MySQL and PostgreSQL as target databases. It also has micro benchmarks for CPU, for RAM, and for file systems or disks. But it can also be extended to benchmark pretty much anything by implementing scripts in the Lua language. Okay, so Sysbench is quite easy to install and set up, which is probably why it has become so popular, especially in the MySQL ecosystem. It is used by leading MySQL performance experts. You may have seen various blog posts on Planet MySQL with all kinds of MySQL benchmarks comparing multiple storage engines or multiple MySQL flavors or multiple MySQL versions. Most of them have been done with using Sysbench. It's also used by QA teams in many companies, including fairly big companies, to basically as a QA tool. If you want to test some changes to your infrastructure or changes to cluster topology and so on and so forth, if they pass Sysbench, that means, well, they're stable enough to pass Sysbench. And yes, as I said, I also use myself Sysbench extensively in what I do. The idea behind Sysbench is pretty simple. This is what absolutely all benchmarks do. They execute something in a loop, and they also calculate time deltas, time required to perform to execute a single iteration. And then after a certain number of iterations, they aggregate all the statistics to produce some nice looking reports like that one. And the only thing which is different across all benchmarks is that highlighted part do something. This is what defines the workload. This is what defines what we actually want to benchmark, right? Yet in many cases, people have to implement all of that from scratch. Implement the workload, and then implement all that code to measure time, to aggregate results, sometimes do it in multiple threads. Implements random numbers generators and so on and so forth. So Sysbench simplifies that by letting users define their workloads by implementing scripts in the Lua language. And then Sysbench does all the heavy lifting, like managing threads, generating random numbers, which is not as easy as it may sound if you want to do it, if you want to generate high quality random numbers and you want to do it concurrently with multiple threads. Sysbench also does stats collection and aggregation and all that stuff. basically all the boring stuff. And here's a working example of a Sysbench benchmark. I'm not going to go into details. Details will be covered by Martin in his live demo. But this is basically a very simple but working example of a Sysbench benchmark. Why did I choose Lua to implement scripting in Sysbench? Well, Lua is incredibly fast for a scripting language. Some people say it's the speed queen of dynamic languages. It has also been designed to be embedded into C and C++ applications. There's a very simple, straightforward protocol that you can use to call Lua functions from C code and vice versa. Lua is also simple and elegant, but powerful at the same time. You can do fairly complex, you can implement fairly complex programming paradigms by just a very few simple underlying concepts. And there's also LuaJIT. LuaJIT is a project which adds just-in-time compiler capabilities to Lua, which take Lua performance to a completely new level. In some cases, under some circumstances, it is possible to achieve native code execution speed with Lua and LuaJIT. And LuaJIT also offers the FFI library, which makes it possible to for Lua and C code to talk without intermediate data type conversions, just pass native data structures between C and Lua. And it also makes it possible for Lua programs to call any C functions from any C library, basically do the same that any C program would do. So while Lua itself is a minimalist programming language, it also has extensive ecosystem. There are libraries for all popular databases, network protocols, file formats, you name it. And there's also a package manager called LuaRocks, which allows you to, basically it's similar to package managers for other languages, like RubyGems, pip, npm, peer, or cpan. It allows you to discover and install those libraries to your system. Here's an example. You can use LuaRocks to install an HTTP library for Lua, and then you can use that library to implement a very simple HTTP benchmark with Sysbench. So Sysbench is not just about benchmarking databases. You can create an HTTP benchmark as well. Yes, last year Sysbench received a major upgrade in terms of functionality, and it also won the MySQL Application of the Year Community Award, which was great. And the main theme, the main topic for that release was versatility. Sysbench became scalable to modern hardware. It also got extended and more flexible API, and also ability to use external Lua libraries. But basically, my goal for that release was to create a solid core, a solid foundation, so that new features could be implemented as extensions on top of existing functionality. And the most common application for those extensions is creating custom benchmarks. With modern Sysbench, arbitrarily complex scenarios can now be implemented with this extended API. For example, previously Sysbench did not allow you to read results of SQL queries, which was okay for the vast majority of benchmarks. But in some complex SQL benchmarks scenarios, you have to actually read SQL query results and process them. So that is now possible. And as a result of those improvements, there's now the first custom benchmark implemented on top of that extended API was sysbench-tpcc by Percona. I'm going to talk about it later. And there are actually more custom benchmarks in the works for SQL databases, for NoSQL databases as well. So sysbench-tpcc. Sysbench-tpcc is a TPCC-like workload for Sysbench, implemented by Percona. For those who don't know, TPCC is an organization created many years ago by multiple hardware and database vendors to establish some common metric, some common language that can be used to compare performance of various hardware and software solutions. I don't think it's relevant today. You can see those quotes. That's because I'm skeptical, because there are many limitations on what you can, what you're allowed to call a TPC benchmark, and how you can do those benchmarks, how you can publish those benchmarks, and so on and so forth. But still, there are some people who believe that this TPC set of benchmarks is more credible than everything else, and it's great that Percona has implemented it as a Sysbench extension. It's also great to have yet another benchmark for Sysbench, because I think the more benchmarks, the better. But those were that was about benchmarks implemented by someone else. Why would you want to implement your own custom benchmark? Well, because no benchmark is perfect. All benchmarks are just approximations for some real-world situations and real-world workloads. And of course, the number of possible real-world workloads is huge. So simulating your specific applications and workloads will give you more relevant results, right? Relevant to your infrastructure and your applications. And you can also benchmark any part of the stack. Not just you can run not just SQL benchmarks, but also HTTP and application servers, or you can also create micro benchmarks in some cases. That is also possible with Sysbench. Here's an example of a micro benchmark. You may have heard about all those CPU vulnerabilities called Meltdown and Spectre. There was a lot of talk about them about half a year ago, and people knew that the mitigations for those vulnerabilities are going to have huge performance impact on applications. But it all depended on the Linux kernel version, CPU microcode version, and so on and so forth. So people tried to figure out what exactly, how exactly the impact, performance impact from those mitigations is going to look like on their systems. And here's a very simple benchmark, the micro benchmark that you can do with Sysbench with just a few lines. It measures the speed of system calls. I'm using the, it doesn't work. The FFI feature provided by Logit. Basically, I declare the syscall function provided by the Linux by glibc. And then in the event, I'm going. This benchmark will run that. Will call that function as fast as it can. And on this system, when I was running this benchmark, it could do about 5 million system calls per second. And that was on a system without Spectre and Meltdown mitigations applied. If I was doing it on a system with those mitigations applied, I could probably see something like 2.5 million system calls per second. So impact can be huge, and you can run a micro benchmark with Sysbench to measure it. But generally, implementing and running your custom benchmarks with Sysbench can help you answer all kinds of what-if questions. Like, what if the load doubles during holiday season? Or what if you change this configuration parameter? How exactly is it going to affect our performance? Or what if we move databases to new hardware or another cloud instance? What if you upgrade database version or migrate to another database vendor? All of those questions can be answered easily by implementing your custom workload and running it with Sysbench. What's also new with Sysbench is this new extension called Tune. I implemented it recently. And it basically summarizes my personal experience in tuning hardware and operating systems to achieve stable, consistent, and repeatable benchmark results. It turns out it's not as easy as it may sound, because modern hardware and modern operating systems do a lot of tricks to balance power consumption and performance, for example. So getting stable and repeatable benchmark results is actually a tricky thing. And previously, I had a bunch of shell scripts that I ran before executing benchmarks. And now I just decided to re-implement that, to re-implement them as a Sysbench extension and publish, make it available for everyone. So this is how it looks like. You can get the list of available tuning profiles, and the only available tuning profile at the moment is called MySQL Bench. And then you can apply that profile, and basically, if you execute these commands, it will start applying all kinds of operating system tuning to get stable benchmark results. There's also SysbenchRocks, which is a repository of Sysbench-specific packages called rocks. It's based on Lua rocks. And the TPCC benchmark developed by Percona, and the tune extensions are already available from SysbenchRocks. And I'm going to publish more extensions and libraries in the future. What else is new in Sysbench 1.0? It's now possible to customize reports produced by Sysbench. Here's the default human-readable reporting format in Sysbench, which I think is massively cool. It's easy on the eyes, but it's a little hard to parse into machine-readable format, which is what you want to do when you want to aggregate and, for example, visualize your benchmark results. So it has been a frequently requested feature to dump those results in some machine parsable format, like JSON, for example. So it's now possible by implementing report hooks. Here's an example of a report hook which dumps statistics in the JSON format. Basically, a report hook receives a structure containing all statistics that Sysbench uses itself to dump reports in the default human-readable format. And you can use those numbers to print reports in whatever format you want. It can be JSON, it can be CSV, whatever. What's next? I'm also working on other further improvements to Sysbench. I'm going to implement other loadable modules, like Sysbench Playback, for example. It's another frequently requested feature. When people want to, instead of simulating their workload by implementing a Lua script, they actually want to record their existing workload and then replay it against the server. There are other tools that do something similar. There's a tool from Percona, which is called Percona Playback, I think. But it would be nice to have the same functionality in Sysbench and also have the same with the familiar interface, with the familiar reporting format, and so on and so forth. Then I'm going to automate results visualization by implementing the Sysbench extension called Sysbench Report. And another frequently requested feature in Sysbench is when people basically want to tell Sysbench, here's my table populated with some randomly generated data. And I'm going to implement it as a Sysbench faker, basically, which generates fake data and populates the table or tables. I also know that Tarantul is a popular NoSQL database in Russia. They're also going to add Tarantul support to Sysbench. And I also know that Percona has been working on a MongoDB version of the standard LTP benchmark. It's already available on GitHub. I'm not sure what its status is, but it's already available. I'm personally interested in running other workloads with Sysbench besides standard OLTP and TPCC, like LinkBench, IBench, or YCSB. So I will also be working on implementing them in Sysbench Lua and making them available on SysbenchRocks. And there's currently no documentation. As most developers, I suck at documenting what I do. So the only available documentation is just the README file in the source repository and scripts. But you can also use existing scripts as examples, and that works for many people. So, but I'm also going to document Sysbench itself and API. And now we're going to see the live demo presented by Martín.
Hello. Okay, so is that good? Okay, so as Alexey mentioned, I'm going to make a small demo, and I'm going to show a few scripts, and I'm going to walk through the process of the creation of a custom script. So first of all, I'm going to show you really quick the basic structure that Alexey just mentioned. One of the things that it's really nice is that Sysbench can be used as an interpreter. You don't have to execute Sysbench and apply the script. You can just use it as an interpreter, like Bash or whatever, and it will do it. So there are 3 steps, and basically are the 3 main steps that you can execute in a benchmark. Prepare are all the tasks that you are going to execute before the event, so prepare the environment for the test. Event is the event itself, and the cleanup process is after you finish the execution of your event, it's what it's going to happen. In this case, whoops, yeah, too many dots. The default value for an execution of a benchmark is 10 seconds. But I think it's overflowing the screen. In this case, as I mentioned before, the event itself, it was just print a dot, and it was able to print like 2.5 million. Okay, that's not really a representative case. You can you can use parameters that are general for all the benchmark. For example, the time. You can do 1, and it's execute for 1 second, and it will use all the parameters that are common for all the benchmarks. You can do it on all your custom benchmark unless you override it. So really quick, then I'm going to show the benchmark 2.0. Okay, this is basically the same as before, but I added a function. In this case, as you can see, you can create custom functions and call those functions from any section of your benchmark, like in the prepare section, and also in the event itself. Okay, so in the cleanup, I don't call it, but it's basically I create this function, which is get a connection. Okay, and this function uses the parameters that are by default on Sysbench, and which are basically, hold on because there are a lot. Okay, and I'm going to explain a bit this. Basically, this is the script, the driver that you are going to use, the socket, the user, the password, and run. And I'm going to do the prepare before, but it's not doing anything in this case. And then I will call the same with run. So this is, in this case, it's the same, 10 seconds, and it will basically make the code that I made, which is basically a select. I'm going to show you that. The prepare is just doing this because I just wanted to verify that the connection, I was able to connect. So it don't return any error. It's fine. And this is the event itself. So each time that I run, each dot, it means that it made us select aster from mysql.user limit 1. Okay? And it was able to execute 26,000 events during those 10 seconds. Okay? But if you want to avoid to have this size of parameters, what you can do is use the sysbench config, which basically you can put the configuration options here. And in this case, you can do just this one. And config file sysbench. And it does the same with the configuration that I sent. As you can see here, it's execute this benchmark for 5 seconds because I added the bottom here. It don't have this one. It's override not only for the MySQL configuration but always for the rest of the configuration that you want to modify. So, and I'm going to open this one and I'm going to explain a bit. As you can see here, we have the function, which is get connection. The prepare get a connection and execute the select. And then we have a new thread, which is basically each time you can overwrite or create event when a new thread is created. And then you have the event itself, which on each event, I'm going to get a connection and execute the select that I was doing before and disconnecting from MySQL. Okay? So this one was generating on 5 seconds. Let me get that number of events here, 13,000. Okay, but I'm going to open the second version, which is basically the same. The prepare is the same, but on the event, I will create the event each time that I initialize a thread. Okay, so in this case, as you can see, I'm not getting the connection, but this variable it's also available on each event. Okay, so I create the variable here on the thread init, which is a defined function that it's building on Sysbench, and I just override, or actually I'm adding options to the initialization of the threads. So, and then the cleanup, which is the same. So in this case, if I do the same, remember this was 13. So basically, if I use the same connection, I don't create the connection on each time that I execute the event. I was able to get 44,000 selects, reutilization, we use the same connection. This also works with multiple threads. So each thread will have its own connection, and it will execute the events. So each thread will create one variable, and it will not be shared with the other threads. So that will be handled by that particular thread. And yeah, we were able to get 83,000 of connections, of selects. Questions so far? You? Thank you. You're a nice person. So, benchmark 3. This is a bit more complex, but still really easy. As you can see here, I'm adding command line options to my custom benchmark. I want to pass a table structure and a table engine, and by default is so this is the description. This is the name, which replaces the underscore for a dash, and this is the description here, and this is the content of the variable itself. So the same with table engine. This is the description, and the default is InnoDB. I set up a global variable here. This is all Lua, and if it works in Lua, you can do it here, basically. The same get connection function, the same thread prepare. Basically, in this case, I run use, and the database name that I'm going to use, just to be sure that that exists. And this is the event. It made the concatenation of of Lua. It's 2 dots between strings. So basically, it creates the table with the name of the table. I also use the variable that it's on the top here, which is the table number. It's right here. Okay. Then this is all to create the table name, right? It's the database here, the table the table number. So it's T plus table number plus thread ID, and then the content, and then the engine. Okay, this basically will create the table, and in this case, the cleanup process is basically drop the database and create the database again, because I want to reuse that for many things. So basically, that's if you want to test the table creation, and or maybe you want to create 10,000 tables, and because you want to test something else, you can do it with this. So okay, so I just clean up just in case, and I'm going to run it. Here you see the number of threads that I'm using, and basically I was able to create 735 tables during this time. And if I go here and run the show tables, you see the number, and basically you see that all of them ends with the underscore 0, which means that it was the thread number 0. But if I run the cleanup,
takes a bit longer. And I run this with thread 4. We should get the number of tables that it was created. It was pretty much the same. But here we see that there is 0, 1, 2, and 3. Basically, it's the thread ID. But the number of tables, so we didn't get too much improvement on that regard. We can also I already my ISOM. We found one good thing of my ISOM. Creation of table is fast. So we were able to create 4,700. And yeah, it created the tables, so the tables are there. If we see show T90, it's pretty much what it was on the default parameter of the script. Okay. So what also we can do after the cleanup, and I'm going to pick this resolution is not good at all. So here, what I do is exactly the same. I pass the same parameters. I run with the parameter that I execute is run. The table structure, it doesn't have the name because I create the name based on the thread ID and the number that it's created. And I create a different table structure. And yeah, it's pretty much the same as the simple one. And if we do the same, here you can see the table is the one that we passed on the parameters. And of course, we can also do the same with adding the table engine my ISOM. Well, here it's just this difference, but basically, yes, it was able to create actually a bit less tables, 1,000 less of my ISOM tables, but yeah, it works, and also all the other options that you can have, like threads and all that, it's available. So what you can do is basically create multiple tests, and as Alexey mentioned, you can modify any parameters and run that again and see what happened, and be able to get at least more realistic results. So that's pretty much it. If anybody have any question, this will be we will share these scripts on GitHub. That will be on the slides when we upload it. I'm not sure where, but we are going to share that. So yeah, that's it. Questions?
I have a question.
Yes.
Is there some way, maybe it's a Lua scripting thing, is there some way to throttle the work? You know, Sysbench is all about doing as much as it can, as fast as it can. But that's not really realistic.
This is
So-
part, sorry. This is the part that I passed the microphone to him.
Yes, Sysbench has bounded rate mode, and it works for any script. You can just limit the number of events executed per second. So it works for any benchmark. You just say double dash rate equals 100, and then it means.
So it doesn't spread it out, it just basically executes X per second and then stops until the next second? Is that how
No, I see where you're going. Basically, it's this coordinated emission problem that some people are talking about. No, Sysbench doesn't have this problem. First of all, it's not just the distribution of interval between events is not uniform. It has the Poisson distribution. And if it's unable to, for example, to reach the database, if it's taking too long, then it measures the time between the event has been put into the queue and between the event has actually been executed. So the time to execute that event will be measured. The total time between putting it into the queue and executing it. This is all will be recorded in statistics. Okay. Thank you.